Thank you, Dr. Yang, for the invitation. It's my honor to give this guest lecture today. My name is Chusen Wu. I'm an assistant professor at the University of Tennessee. The title of my presentation is Introduction to Google's Engine Python API and geemap. The Google slides for my presentation can be accessed by scanning the QR code at the lower right corner, or go to the URL gshub.org/UWYO. Here is the outline of my presentation. First, I will briefly introduce Google's engine and also talking about the motivation behind why I developed the geemap Python package. Then I will show you some tutorials and also highlight some key features of the geemap package. And lastly, I will show you some additional resources if you want to learn more about Google's engine and geemap. And I will be happy to take any questions at the end. So on the right here is a lane set time-lapse animation from 1984 to 2020. And this is something you can create using geemap and Google's engine within just a few seconds. So you don't need to do any programming. You just simply draw a rectangle on the map, and then you'll be able to customize and to create something like this for any locations on Earth surface. You can try out this app here by clicking the link upper right corner, app 1 and app 2. You can also click the notebook to see the source code behind how this was developed. So next, I'm going to show you the quick demo what this is about. So you can go to the URL and then you can source any location, or you can zoom to using the tool to zoom into any location. Then you just draw a rectangle on the map or a polygon, and then you can customize the title, also bank combination. You can also change, for example, the start months and end months, right? Depends on the season that you are interested in. You can also select a normalized difference index if you want to extract, for example, water or vegetation. And so after that, you just click a button. You will be able to create something like this, and you will be able to download this animation to your computer. Then you can share this on your website or social media. And keep that in mind, this is like you can do it for any location. So you can do it for any location around the globe that you're interested in. So next, I'm going to show you some examples that are very interesting and striking. So the first one here on the left is the drawing of the ROC from the same like 1984 up to 2020. So you can see the dramatic shrinking of the water surface. On the right here is mining in Alberta, Canada. Also here is the left one is coastal expansion in Dubai, and the right here is river dynamics improve. It's also the same one you see in the outlines slides. The one here on the left is deforestation, and on the right here is showing you the landslides, right? So this is very striking because the landslide lasted for many years, and you want to be able to see that on site. You can only see that from long-term remote sensing satellite imagery. And so this one is Las Vegas, urban growth, and also you can see the shrinking of the reservoir. This one is for urban growth in China, Dongguan City. Here is the time lapse for the University of Wyoming and its surrounding area. As you can see from the time lapse in here, there's fast growing here in the surrounding area. For example, in the lower left, lower right corner here, and also somewhere here, this corner, and also I think this one is a lane field side. And also you can see the legs in here appear, I think in the late 1990s. Also somewhere here down below, there's also fast growing and urban expansion in the surrounding area. So this is a nice way that you can visualize the changes in the area. And like I said, you don't need to write any live code. You can just use the web app to quickly create animation like this within a few seconds. Next, I'm going to briefly introduce Google Earth Engine. For those of you who are not familiar, it's a cloud computing platform provided by Google. And if you have not used this before, you probably heard about Google Earth. So and Google Map. But these are very uh, different products. Okay, so Google Earth, basically you can view the imagery, you can navigate, but you cannot do any analysis. So the Earth engine, actually the compute engine behind Google Earth, and some of the imagery that you see on Google Earth actually are created using Google Earth engine. And here I'm going to give you an analogy. Google Earth engine and Google Earth is just like on Windows system, you have image viewer, and you might also have Photoshop, right? So image viewer, you can just view any imagery use on the Windows system, but Photoshop, you can do a lot of more complicated analysis. You can do cropping, you can do mosaicing. There are a lot of things you can do using Photoshop. So this is just a simple analysis to show you the differences between these two products. And Google Engine is free. You can sign up. Go to the website. You can sign up using your EU account, and usually it's instant approval. If you use Gmail, it might sometimes take a while. Okay, so make sure you use your Gmail, EDU email if you have one. And so it is free for research, education, and non-profit use. And one of the very common application about Google's engine is to create, for example, cloud-free imagery. So if you do remote sensing, you probably know that cloud is one of the major problem for optical remote sensing. So for example, in this imagery, right? So at any time during the year when the satellite captures the imagery, it might have cloud. So some pixels are cloud-free, but there are a lot of pixels that actually have cloud. And if you use Google Earth engine, you just need basically one line of code, and then you can create some cloud-free imagery like this. So if you use Google Earth, when you navigate Google Earth, you probably notice that most of the imagery looks very nice, and they don't really have any cloud. But keep that in mind, those are not real, the original raw satellite imagery. Some of those actually processed using Google's engine, and then the data being accessed by Google Earth. One of the biggest advantages of Google's engine is that it has a huge data catalog. So right now it has more than 35 petabyte of data. So 1 petabyte is 1,000 terabytes. So it has more than 35,000 terabytes. Think about that. If for personal computer, there's no way you can store this kind of volume of data, and it's still growing. So it's more data being added basically daily, and most of the common satellite data we are using, most of them right now are available within Google's engine data catalog. For example, Landsat, Sentinel, MODIS, also land use, land cover, weather, and climate. So, and if the data set that you want are not available on Google's engine, then you can upload data to your own account. Each account has 250 gigabytes, so it's still pretty decent storage that you can use to process data, something that you want to use but not available publicly. And Google's engine provides two APIs. So the first one here is the JavaScript code editor, and this is the interface. And you can go online. You can most users get started with the code editor. This is the default API. All the documentation provided by Google are actually written using the JavaScript API, and it's pretty simple and straightforward to use. It's not the focus of our talk today, but you can also click the link at the lower right corner to just one simple example how we can utilize Google's engine to quickly, for example, extract water. On the other hand, the Python API, it has relatively limited documentation and tutorials, but lots of users actually learned Python, and but the downside is that Python, Google Earth Engine does not provide a lot of documentation, and it's also not basically it's not the default language provided API provided by Google. So and there are not a lot of documentation or tutorials, so user might sometimes having a hard time actually to get started. And But the advantage of Google's Python is that it has a lot of packages that you can utilize, and you can also integrate with a lot of open source packages. Also, for example, QGIS, and for example, you can also integrate with Jupyter Notebook or Visual Studio Code. So this is something that is a gap in there that I'm trying to address, because Python has a lot of potential, and it's much easier to use than JavaScript. So this is what the gap that I'm trying to fill. And so in here shows you the interface. This one is actually the JavaScript API. So the JavaScript API, you can think about Google's engine has two components. So the first one is doing computation, and the second one is doing visualization. Okay, so JavaScript API has both. You can do computation, but you can also visualize the data set. You can also do computation and show you the output, and you can also create some web app. But the Python API only has computation. It has very limited capability in displaying the data, visualizing the results. So on this slide here, you see the red crosses. Those are things that are not available in the Python API, and this is something that I have been trying to implement, so that can Python users can also easily access the computation, but you can also visualize the dataset easily, and sometimes it's even easier than the JavaScript API. So eventually, what we want to do is that we want to utilize the Jupyter Notebook ecosystem, and so use the Google Earth Engine to do the computation, but we use the Jupyter widget to create interactive components so that user can interact with the map. You can also visualize and analyze the data easily. So this is what geemap is about, and it's open source project. You can check the link on GitHub webpage, and so far it has been used by a lot of people, and you can see it has been started by more than 900 people, and many people find this useful, and that's why I'm continuing to contribute to this project. You can run it using Google Colab, or you can run it in Jupyter Notebook. So I provide a lot of tutorials. I will show you in a minute. So you can install using either PyPI or Conda. You can also install from GitHub. I also have tutorials showing you how to install the package, so it's very easy to use. You can check out the tutorial later. Okay, and so there are two ways you can use geemap. You can use in Google Colab, or you can use on your local Jupyter Notebook. So Google Colab is basically a cloud computing environment provided by Google. You can use that to do Python programming, but the downside is that it does not support IPyLiblet. So geemap basically the computation relies on Google Earth Engine, but the visualization we rely on two Python packages to do basically plotting, visualize the data. In Colab, we need to use the Folium, but in Jupyter Notebook, we use so-called IPyLiblet. IPyLiblet is much better, and it has a lot more functionality. But Google Colab has some limitations, so it doesn't support IPyLiblet. So that's why we use Folium. And also on the left side here, show you some notebook template and Visual Studio video tutorial. You can click the link to execute the source code, and here shows you the kind of a simple example. What you need to do is to import the library, and then you create a map, X some data, and then you display the map. That's it. So and between there you can do a lot of analysis, but this is kind of a general procedure, right? You can create a map and then get the data, do some analysis, and then display the map. I also published a short paper describing the package, so you can check out the link if you want to learn more. And I also create a website. You can check out the website geemap.org. Has a lot of documentation how to get started, and also tutorials, also the API documentation. You can check it. For example, there are a lot of functions. I think right now has almost 400 functions that you within the package. So you can, if you're interested in learning more, you can click each function, and you will be able to see the also the documentation, but also the source code. So if you want to contribute to the project, you might want to learn some of the source code, basically how the package was implemented. Next, I'm going to show you some tutorials. So if you check out the YouTube channel, so I have a lot of Earth Engine tutorials. So for the geemap right now, I have developed over 53 tutorials and almost 12, 14 hours, and each tutorial is about 15-20 minutes. And so, but the more time consuming part is actually to develop those new features that introduced in those tutorials. So I spent a lot of time because originally I developed package for my students. I was teaching programming course here at the University of Tennessee, and because there are not a lot of documentation and tutorials available for the Google Earth Engine Python API, and I developed the package and then released to GitHub. Many people find that useful, and that's why I continue to develop and also maintain the documentation, also video tutorials. And so far it has more than 100,000 views for the YouTube channel, and also a lot of subscribers. Here shows you a list of the tutorials. So as I show you, I have developed almost 58 tutorials. So each one has a full-length video of 15 to 20 minutes. Also a short animation, usually within 30-40 seconds, but also a Jupyter notebook example. So you can reproduce exactly what I did in those tutorials, and then you'll be able to go through the tutorial using the notebook, and then you can customize the notebook if you want to change using old data, something like that. So you're welcome to check out the link to learn more about the package. So next, I'm going to show you some of the key features, like what you can do, right? So this is something that you can utilize. Just use a browser, and then you can do cloud computing. You can do all kind of geospatial analysis. You don't have to have a fancy, powerful computer. You can even do that using your iPad or your cell phone. So the first one is about converting Google Earth Engine JavaScript to Python without coding. If you already know Google Earth Engine JavaScript, you can use this too. So here shows you the interface. All you need to do is just copy and paste, and then you should be able to convert the JavaScript to Python, and you just execute. So in that way, you don't really have to do any coding. So you can automatically convert JavaScript to Python easily. You can also do search the entire Earth Engine data catalog. I mentioned earlier it has 35 petabyte of data, and in the past we have to go to different agencies, for example NASA or USGS, to download satellite data and then do some pre-processing, and then you can load it into, for example, Envy or ArcGIS. But using Google Earth Engine, you just need a browser, and all you need to do is just to type in some keywords, and then you can import the data, and then you can load it onto the map, and then you can do analysis. So it saves you a tons of time, because some of the data set has been have been pre-processed, and you can just directly use those analysis ready data set without having to download anything. You can also change the base map. Google Earth Engine, if you use the JavaScript API, it only has the Google base map, but there are a lot of web services out there, and so if you use Python, you have a lot more options that you can choose, and there are tons of base map that you can incorporate into the map. So in that way, you don't have to download the data. Sometimes you just want to do a quick comparison. This is a way for you to do that. You can quickly add just the base map just using a free lines of code, and then can bring in the data. This is something the JavaScript API cannot do. You can also change the layer visualization interactively. For example, change the layer opacity, turn the layer on and off. This is similar to the JavaScript API, but also provide a lot more controls. You can customize, for example, band combination, and then just click and you will be able to apply. You don't have to write any line of code. In this case, you can change, for example, Landsat data or with multispectral band, or you can do that for one single band. Very easy to do. So even if you don't know how to do the coding, you can still visualize data in interactively. You can also create a split panel map. So this is especially useful if you're trying to visualize the changes before or after a certain events. For example, some natural disaster. You can also visualize, for example, urban growth or vegetation or deforestation or water changes, water dynamics. So you can do that for any kind of a data layers. You can also use the inspector, for example, to check the pixel values or polygon attributes, right? So this is just like in ArcGIS, the identifier. You just select the data layers and then you click on the map. It will query the Earth engine data, okay? And then so basically when you click on the map, it retrieve your the coordinates and then send the coordinates to Google's engine and then get the data, return the results, and then display the results. Again, you don't have to write any line of code. Everything is interactively. And this looks very easy, but behind the scene there are many lines of code. So basically I do the coding. So in that way you don't have to do the coding. Besides using the inspector to get the pixel values, you can also plot Earth engine data. For example, in this case, Landsat data, you can plot the spectral signature. Click on the map and then you can easily get this. You can also export the spectral signature or the data. In addition to multispectral data, you can also do it for hyperspectral. So for example, in this case is Hyperion hyperspectral data. You can get the pixel values from hundreds of bands just using one click. So though Earth engine has a lot of data, but sometimes not all the data available on Google Earth engine. You might have some local data set you want to use. For example, in this case, some vector data. You might also have raster data. So geemap also allows you to open data on your local computer, and then for vector data, you can convert to Earth engine objects, and then you can use that to do cloud computing. But you can also add local raster data. This is something that Google Earth Engine JavaScript API cannot do. So if you're using the JavaScript API, you are limited to the browser and everything is within the interface. You cannot communicate with your local computer. But using geemap, you can pass data from your local computer and then you can send it to Google's engine, or you can just using the local data to do some computation. You can also change, for example, change the visualization if you want. Okay. Next one is about the white box. I'm not sure how many of you have used this. The white box is a open source geospatial analysis toolbox that has right now 477 tools, and so it was developed by Dr. John Lindsay from Canada. And then I basically built on top of the command line program to develop the interface. And I also integrate this one right now into geemap, so you can access more than 477 tools without having to write any line of code. So you just need one click and then select the tool. This is something similar to the ArcGIS toolbox, but it has a lot of tools that are not available within ArcGIS toolbox. So the good thing about this is like open source. It's independent, so you don't need any third-party libraries. You just need a browser. That's it. If you're talking about ArcGIS, you need to install ArcGIS or ArcGIS Pro, and you need to have a powerful computer in order to do that. But for this one, you can run that using Google Colab, for example. Just open a browser and then click the link. You will be able to do all the computation, and you can download data from the cloud. You can also upload data from your local computer, and it's very easy to do. So this is something that I recently integrated into the geemap package to bring you the capability to not only do cloud computing, but you can also utilize any data on your local computer. If you have a powerful computer, you can also use this one. If you don't have a powerful computer, then you can use Google Colab or other cloud computing platform to do geospatial analysis. Okay, next one is about visualization. So earlier I showed you can change the layer opacity, but you can also change, for example, the color map. There are lots of options for you to choose from, and you can also, for example, based on the color map, you can also add a legend to the map, and you can also do that for example, elevation data or any kind of a raster data. Okay, so you can do that for Landsat. You can change the band combination. You can also change, for example, the range. This is something similar to, for example, ArcGIS. You can open the properties. You can change the symbology. But again, those are desktop software. But right now, there's no something other open source packages that you can directly use that on the browser and then to do this kind of interactive mapping stuff. Okay, so next one is about vector data. So you can load the vector data from a local computer, or you can load vector data from the Google Earth Engine data catalog. And once you load the data, you can change the symbology. You can customize the map based on, for example, a certain attribute. You can change it to just for example, the outline. If you don't want to see the color being filled, you can also change, for example, the opacity. You can change the outline type. You can change the color. So there are a lot of things you can customize. And again, this looks very simple to use, but behind the scene, this one is more than 1,000 lines of code. So it took me a long time actually to implement something like this. And these are all using iPyLib, and iPy widgets. It's very powerful. So a lot of potentials. But this is just showing you some demo, and there are a lot of things you can do. So if you have any suggestion, if you have like anything that you think you can improve, let me know. I'll be happy to incorporate those components. As you can see, right, you just change some settings. You can just click a few buttons, then you can produce some pretty decent looking maps. Besides just doing the visualization, right, you can also do a lot of analysis. One example is doing machine learning. So you might want to do supervised classification or unsupervised classification. You might also want to do some accuracy assessment. So this is also something you can do using Google's engine. And again, you don't have to have a powerful computer. The other advantage that the location doesn't really matter. So if you, as long as you develop a methodology, you can apply it to global scale, so much larger scale, because the dataset, most of the things, dataset available on Google Earth Engine is like a larger scale, global scale, or continental scale. So if you figure out the method for a specific area, then you can just using a few lines of code, you can expand to a much larger area without having to change a lot of lines of code. Besides doing Google's cloud computing and machine learning, you can also visualize using 3D. So this is also something you can do using a browser without having to have, for example, install ArcGIS or ArcGIS Pro, and you can do visualization using 3D. In this case, it's elevation data in the US, but you can do it at the global scale. Besides doing computation and visualization, like one thing that in the academia we want to do is to publish, right? So if you want to publish in journal articles, if you already create some algorithm and produce some maps using Google's engine, you might want to also export some maps. So traditionally, you might use this, for example, in the create some maps using the professional software, for example, ArcGIS or other software packages. But actually, geemap also has some functionality, allows you to create some maps. That's something like this, a nice looking map. This is global scale, but you can also do it for a smaller scale or continental scale. And as long as you have the data, you can pull the data out and then create a map like this very easily. And I also have the full tutorial. You can check out the tutorial. Similarly, besides creating maps that you can put that into your journal publication, you can also create interactive maps because some of the maps that you create might be static, but it would be nice to have some interactive maps that you can, for example, embed into social media, so other people can also visualize your data and your products. So this is also something you can do using geemap easily, just one line of code. And once you create a map, you can publish the map, and all you need is just a link. So it will generate a short URL, and then you can send the URL to anyone. They will be able to open the link, and the map will still be interactive. So the Earth Engine data computation result will still be interactive, and they don't have to have an Earth Engine account in order to visualize your data set. And this is very nice because I just make your data and your products widely available. So anyone has internet access, they will be able to visualize your data products. And I think this is the maybe the last feature I'm going to show. And again, you after you have done some computation, you have get some result, you want to show the final output to people. But besides generate the interactive map, sometimes you might have a server, you want to hold something on your server. So one example I showed you earlier is that for the creating the lane set time-lapse animation. So those are something that you can, it is the web interactive app that you can create it using Geemap, and they can host it on your local computer, or you can host it on some other server. And so in that way, people just go to the link and then they can interact with the map. They can change the parameters and then to create some maps without having to write any line of code. Because if you know how to publish the app, basically it's just a Jupyter notebook. So you can turn the Jupyter notebook directly into a website. So in that way, you don't have to do a lot of work actually to build a website. If you know how to use the Jupyter notebook, you can create the app. So the app, if you want a lot of interactive components, you can develop using iPad widget. So this example here shows you how to create, for example, the time-lapse animation, and you have loads of drop-down lists. You have the slider. You can also have the checkbox. You can also change the color. So there are lots of options you can use. And once you develop the novel example, then you can just using a few lines of code to convert this one to a standalone website. And I also have a tutorial showing you how to do this step by step. So this is something that you might want to use if you want to publish, for example, in your journal article. You might already develop something using Geemap or Google's engine, but at the end, if you just get the data will be static. But if you have an interactive app, if anyone can visualize it, anyone can look at this, you'll be much better. So this is something that will be useful if you want to publish. So the last one here I'm going to show you is how, for example, you can publish the app, and this is showing you how we can use, for example, Google Search Engine to map surface water dynamics. So in this example, it's showing you the mapping the surface water for the entire US, and as you can see here, you can allow the users to select any watershed, and they just click on the map, make some adjustments in those parameters, and then you can see you can quickly extract the water area and the temperature. You can also export the computational result to your local computer. So if you want to do some more statistical analysis using the data that you exported. And again, this is just a demo. You can do that for any location around the globe. The location doesn't really matter. So you can also allow the user, for example, to draw a simple rectangle on the map. And then once you create a rectangle, you can allow them to, for example, to extract surface water or vegetation. So everything here behind the scene, you can quickly generate using Google's engine. I also provide the Jupyter notebook example. So you can click the link here to take a look at the notebook, the source code, how this was developed. And with this kind of example, you can customize the code and you can change it to your study area. This is just a demo. It's not going to be perfect for like accurate surface water mapping, but showing you the power of Google's engine and Geemap, that you don't need to have a supercomputer. You don't need to have a very complicated coding skills. You can just use the example I provide, and then maybe change the location. You use some other data set you can build on top of some of the example here to make to do more complicated geospatial analysis or applications. Okay, so that's all for the some of the key features that I show, but those are just a small portion of the features of the geemap package. If you want to learn more, you can go to the website geemap.org to take a look at more tutorials. As I mentioned earlier, I had almost 60 tutorials, but I also have some other tutorials showing you how to actually develop package like that. So you can check out my YouTube channel for more tutorials. You're also welcome to ask questions using the GitHub discussions. So a lot of people have used it to ask questions. Maybe I can show you here. Click the link to show you some of the questions. So this is people, anyone can ask if you have a GitHub account. And so most questions are being addressed pretty quickly. And if you run into any issues, you can also open an issue. So far I have resolved almost 200 issues. Some are like feature requests, sometimes some bugs. So you're welcome to submit through here if you have any. And so you can also check out the other repo with 360 Jupyter Notebook examples. So those are some of the examples that I converted from the Earth Engine JavaScript API, and I have converted all the examples. So in that way, you don't have to convert by yourself, and it covers all the topics of Google's Engine. So if you're new to Google's Engine, if you're interested in learning more, you might want to check out this one. You can also check out the YouTube channel, and also I have a blog that I sometimes post tutorials for G or some general or Python. And so let me show you in here. This is the 360 notebook examples. Again, you can check out the list here, the table of contents. It has a lot of examples. So, and all you need to do is just to click, for example, any link, and you're able to click, for example, run in Google Colab. So if you once you have the account, you don't have to install anything on your local computer. So all you need to do is just to click the link, then you can execute through this. You will be able to get the result and also show the map pretty much instantly. So this is something that you can try out if you want to see the computing power of Google's engine. And that's all. So thank you very much for your attention. I will be happy to answer any questions you might have.